everyone, it's Mrs. Martello. We're going to look at section 5.7, which goes along with 5.6. We're looking at linear inequalities, but now we're going to look at a system of linear inequalities. So it's going to be two or more linear inequalities together. So a system of linear inequalities is a set of two or more linear inequalities in the same variables. So here would be an example of a system of linear inequalities. The solution of a system of linear inequalities in two variables is an ordered pair that is a solution of each inequality. So basically, it has to be a point that makes both of those inequalities true. Not just one, not just the other, but it has to be true in both, just like how it is with a system of equations. So let's take a look at example 1. Tell whether each ordered pair is a solution of the system of linear inequalities. So here's our system. Y is less than 2x and y is greater than or equal to x plus 1. We want to test both of these points. So let's take the point 3, 5 and let's plug it into our first inequality here. Just be careful, remember that the 3 is x and the 5 is y. So this would be y, which is 5, is less than 2 times 3. We get y is less than 6, which is true, so that's good, but we're not done yet. We need to test the same point in the second inequality. It has to be true in both. So let's plug 3, 5 into the second one. Y is greater than or equal to x plus 1. So 5 is greater than or equal to 3 plus 1. 5 is greater than or equal to 3. So that means that this point is also true in the second inequality. So because the ordered pair 3, 5 is a solution of the inequality of each inequality, it's a solution of the system because it makes both of them true. Now let's see what happens with the point -2, 0. So if I take the point -2, 0, again, be careful, remember this is x and this is y. We're plugging it into that first inequality, y is less than 2x. So 0 is less than 2 times -2. We get 0 is less than -4. This is false. Right away, if this is false, that means our answer is no. We actually don't even need to check the second inequality. As soon as the point is false in one of them, then it can't be the solution of the system because it has to be true in both. Okay, let's take a look over at graphing our inequalities, our system of inequalities. So when we graph the system of linear inequalities, it's the graph of all the solutions in the system. So what we're going to do is we're going to graph each inequality in the same coordinate plane. So here's our example that we were talking about earlier. You're graphing the line. Don't forget if it's dotted or solid, and then you're going to shade. So this one was shaded below because it was less than. Then you graph the second line, dotted or solid. This one was shaded above because it was greater than, and it's solid because it's or equal to. This one was dashed because it's just less than. And then the intersection of the half planes are the solutions of the inequalities. So this overlapping region right here where the red and the blue shading you can see here is overlapping, this is where all of the solutions would be. So I can pick any point in this overlap, just in this little V here. This is where the solutions are because these points are true in both inequalities. It's true in the blue inequality and it's true in the red inequality. Let's take a look at example 2. So in example 2, we're going to graph the system of linear inequalities. Y is less than or equal to 3 and y is greater than x plus 2. We're going to do one at a time. So first, let's graph this first one. If it's just y and a number, this is going to be a horizontal line. If it's less than or equal to, because it can equal it, this is going to be a solid line. So let's go to our y-axis up here at 3, and we're going to draw a horizontal line, solid line right through y equals 3. Then because it says it's y is less than or equal to 3, I need to shade. So less than means I'm going to shade below. So look at this blue shading is all below the line. Let's look at our second inequality. Y is greater than x plus 2. So we're going to start at the y-intercept up at 2 on the y-axis. And then we're going to use our slope here, which is 1, or you can say 1 over 1. And I would go from the y-intercept up 1, right 1, up 1, right 1. Or I can go the other way, down 1, left 1, down 1, left 1. When I draw my line, this is not equal to, it's just greater than. So this would be a dotted line. So I would use a dotted line to graph this line. And now we're gonna shade. Because it's y is greater than, we're gonna shade above. So it would be everything above the line up here, so you can see the red is where it's shaded. So now we're gonna find the solutions, and the solutions are in this V right here where the two shadings overlap. So this is where the red and the blue shadings are both. This is where the solutions are. So they gave one possible solution. You don't have to necessarily say this, but if you wanted to find a point that would be a solution, you would just pick a point that's in this overlapping shaded region here. Okay, let's take a look at example 3. In example 3, we have the inequalities 2x plus y is less than -1 and 2x plus y is greater than 3. We have to graph them. I'm going to show my work for this one because these are not in slope-intercept form. And to graph them, I think it would be best to solve them for y. Solve for y so that I can make them into y equals mx plus b form. Now you can graph from this form, but you would have to do the x and y intercepts, which is totally fine too, but I like solving for y. So let's do one at a time. I'm going to take the first one, 2x plus y is less than -1. Let's solve for y. We're going to subtract 2x from both sides. I get y is less than -2x minus 1. That would be our first inequality in slope-intercept form. Let's get our second inequality. 2x plus y is greater than 3. We're going to solve for y. We're going to, again, subtract 2x from both sides, and we get y is greater than -2x plus 3. There's our second inequality. So now that we have our two inequalities, we're ready to graph them. So let's do one at a time. We're going to start at -1 on the y-axis. So that's this blue line here, -1. And then our slope is -2 over 1. So remember, rise over run. We're going to go down 2, right 1. So from our y-intercept, down 2, right 1. Down 2, right 1. I can go the other way, up 2, left 1, up 2, left 1. Think about your line. Because this is less than, not equal to, this is going to be a dotted line. So this blue line here is dotted. And then think about where we're going to shade. Because it's less than, I'm going to shade below the line. So everything under the line here is where it gets shaded. Let's do our second inequality. Y is greater than -2x plus 3. We're going to graph the y-intercept of 3. So here it is on the y-axis. And now we're going to do our slope. Again, is -2 over 1. So I'm going to go down 2, right 1, down 2, right 1. Again, let's think about our line. This is going to be a dotted line because it's not equal to. And think about your shading. This is greater than, so I'm going to shade above the line this time. So here's the dotted line, and then they shaded above the line. Now let's think about what the solutions would be. Remember that the solutions are where these two half planes intersect. But these two shadings don't intersect at all. There is no overlapping shaded region. So because there's no overlapping shaded region, that means that this system has no solution. So this would be an example of a no solution system, an example of a special solution. Okay, we're gonna look at some more. Let's take a look at monitoring progress number 4. We're gonna do that one together. Let me write down my inequalities. Y is greater than 2x minus 3, and y is greater than or equal to 1/2 x plus 1. Okay, we're going to graph this system on our coordinate plane here. We're going to do one at a time. Take it nice and slow. We'll do the first inequality, then we'll do the second inequality. Just do one at a time. All right, let's look at our first inequality here. We're going to start at the y-intercept. They're both in y equals mx plus b form, so I'm ready to graph them. Our y-intercept of the first one is -3, so I'm going to go down 3, plot your y-intercept. And then let's use our slope. Our slope in this one is 2, or I can say 2 over 1. So we're gonna go up 2, right 1, up 2, right 1, up 2, right 1. I can go the other way, down 2, left 1. Okay, that should be enough. So for this inequality, because it's just greater than, it's not equal to, this is gonna be a dotted line. And greater than means we're gonna shade above the line. Okay, so let's draw a dotted line here. We're just using dashes. Still wanna put arrows at the end because it still is a line, so it does go on forever. And we're gonna shade above, so everything up here is where we want to shade. This is where all the solutions for this inequality would be. Okay, let's do our second inequality. Again, it's in slope-intercept form. Let's start with the y-intercept of 1. So here's positive 1. And now we're gonna use our slope, which is 1 over 2. So rise over run, we're gonna go up 1, right 2. Up 1, right 2. Up 1, right 2. I can go the other way here, down 1, left 2. Down 1, left 2. Okay, let's think about what kind of line is this gonna be. Look at the inequality symbol. Notice how it's greater than or equal to. So because it's or equal to, this is gonna be a solid line, and it's greater than, so again, we're gonna shade above the line. So here we go, let's connect these points with a solid line this time. And we're shading above this line. So everything above this line up here is where the solutions are. All right, so now let's think about where are the solutions to this whole system, to both of these inequalities. Is this top V up here? So I'm just gonna make this a little bit darker. It's just this V where those two shadings overlap. So it's above the dotted line and above the solid line. So this region right over here is where those solutions are. Let's do another one. We're gonna take a look at monitoring progress number 5. And what we should notice about this one is these inequalities are not in slope-intercept form. So why don't we solve for y so that we can make them y equals mx plus b so that we can graph them. All right, so here we go. We're gonna take one at a time. We have negative 2x plus y is less than 4. Let's solve for y. We're gonna add 2x to both sides, and we get y is greater than 2x plus 4. Let's do our second inequality. 2x plus y is greater than 4. We're gonna solve for y. Let's subtract 2x from both sides, and we get y is greater than negative 2x plus 4. All right, now that our inequalities are in slope-intercept form, now we can go ahead and graph them. So let me go over here to my graph paper. Okay, I'm gonna write down my two new inequalities that I found over here from putting them in slope-intercept form. We have y is less than 2x plus 4, and y is greater than negative 2x minus 4. Okay, let's graph this. We're gonna show our intercepts here, our axes. All right, and we're gonna graph one line at a time here. I'm gonna make this a little shorter so we have a little bit more room. Okay, let's start with our first one. This is y is less than 2x plus 4. We're gonna start at the y-intercept of 4. 1, 2, 3, 4. And let's use our slope, which would be 2 over 1. We're gonna go up 2, right 1. Let's go the other way. Down 2, left 1. Down 2, left 1. Okay, now be careful. Think about what kind of line is this going to be. because this is just less than, this is gonna be a dotted line, and less than means we're gonna shade below the line. Okay, so let's do that. Move this over so you can see. All right, we're gonna do a dotted line here. And we're gonna shade below the line. So all of this down here is where we're gonna shade. Okay, let's do our second inequality. So we can think about the y-intercept. Oh, this is supposed to be +4. Sorry, they're both +4. Let's think about the y-intercept here of this one. We're gonna start up at 4 again. So up here at +4, same y-intercept. And now let's use our slope. So it's -2/1. Negative means we're gonna go down 2, right 1, down 2, right 1. Okay, think about your line. Look at this inequality symbol here. Because this inequality is just greater than, it's not equal to, this is gonna be a dotted line. And because it's greater than, we're gonna shade above the line. Okay, let's draw our dotted line through these points. Again, we're using dashes with arrows on the ends. And we're gonna shade above this line going up this way. So it's all of this up here. So then we can see that the solution is in this V here. So it's below this dotted line and above this dotted line. So that's this V right over here. All of this is where our solutions would be. Now, if you're not sure, you can pick any point in this region over here, plug it in and test it out and see if it makes it true. And it should make it true in both of those inequalities.